Hi everyone, this is the second part of the 2.2 notes, polynomials with a higher degree. We're going to look at example 7, which is Newton's law of cooling. You may have seen this in your science class. The rate at which an object cools varies as the difference between its temperature and the temperature of the surrounding air. When a 270 degrees Celsius steel plate is placed in the air that is at 20 degrees Celsius, it is cooling at 50 degrees Celsius per minute. How fast is it cooling when the temperature is 100 degrees? So what we're going to do is we need to figure out the constant, which is the rate at which it's cooling. So we're going to solve for K first. So we'll set this up into two problems. Here is R equals K, and then T sub O is the initial temperature and T sub S is the surrounding temperature. All right, so the rate of cooling, when we look at that, it says at the beginning it's cooling at 50 degrees Celsius per minute. So in place of R, we're going to put 50. And then we're going to leave K, that's the constant, which we're going to solve for first. And then we're just going to plug in what we know. So T sub O is going to be the initial temperature. And it says 270 degrees was the initial temperature. And then T sub S is the surrounding temperature, and it says it's placed in air that's 20 degrees. So 20 is your surrounding temperature. So now what we want to do is just simply solve for K. So 50 is equal to K times 250, and then divide by 250. And K is equal to 5 over 25, which is 1/5. So my constant is 1/5. Now we're going to go up and we're going to actually answer the question. The question is, how fast is it cooling when the temperature is 100 degrees Celsius? So we're going to take the equation R equals K times T sub O subtract T sub S. So R is the rate of cooling. That's what we're looking for. That equals, the constant is 1/5. The initial temperature, how fast it's cooling, is it cooling when the initial temperature is 100 degrees? So T sub O is now going to be 100, subtract, and the room is still 20 degrees Celsius. So R is equal to 1/5 times 80. So R is equal to, 5 goes into 5 once, 5 goes into 81, 16 times. So 16 is going to be the rate of cooling. And so since it's cooling per minute, we would say 16 degrees Celsius per minute would be the rate for the 100 degrees Celsius object. So this problem, you're going to use your graphing calculator, and you're going to go to y1, and you're going to graph x cubed subtract 31x squared plus 28x plus 60. What a hidden behavior is when I graph this using a standard window, you can see that I only see 1, 2 zeros. But because this is a third degree, we know that there are actually 3 zeros. Now, your choices with 3 zeros is you could have 3 real zeros, or you could have 2 imaginary, because imaginaries always come in pairs, and 1 real zero. And because I already see 2 real zeros, I know that my choice has to be 3 real zeros based on that degree of 3. So with my graphing calculator, I'm going to need to take my window and I'm going to need to zoom out so that I can see all 3 zeros. And I'm going to switch to my calculator and show you how that works right now. So here you can see I went to y1 and I put in my equation, and then I'm going to go ahead and do a zoom 6. So when I hit zoom 6, you can see that I have two zeros. I have one at -1 and one at 2, but I'm missing that third zero because the degree is 3. And so I'm assuming that this is going to come up, it's going to curve around, come down, curve, and then back up on the right-hand side. And that's because the leading coefficient is positive. So I know that this graph is going to end on the right-hand side. So if I go to Window, I can switch my X max to 40 and then maybe count by twos, hit trace, and I'm probably going to see, oh, what happened? Let's go back to Window. Oh, that's a 4. 40, let's try again. 40, hit trace, and I'm probably going to see that third zero. So here you go. Here's that third zero. Now, when you're calculating the zeros, if I hit second trace and then pick option number 2, which is 0, what's going to happen is I'm right arrowing over to get closer and closer to that 0. I'm kind of looking at those y values. And do you see how those y values are negative? It's -500, -194. And now do you see, I keep going, and now it jumps to a positive. So the 0 is in between the -194 and the +132. I had a sign change. So if I want to be left of that 0, then I'll hit enter on the negative and then right arrow, and now I'm positive, hit enter, and then that's my guess. I'll hit enter, and my 0 is at 30. So intermediate value theorem is going to help us find the zeros. So how this works is it says if A and B are real numbers and A is less than B, and if F is continuous on A to B, then F takes on every value between F of A and F of B. So let's just pretend, here we go, what this means. So it says A is less than B. So if this is A, I would say this is B. And what it says, then up here, I could call this F of A. And I could call this down here F of B. And it says this is continuous. So you can see that this is something continuous from F of A to F of B. And so it says, therefore, if F of A and F of B have opposite signs, notice F of A is positive and F of B is negative, then F of C is equal to 0. So this right here is going to be C. And F of C is equal to 0. It says, so F of C equals 0 for some number C in A to B. So C is going to be our 0. And we get this sign change here. So let's try example 9. It says we're going to use the intermediate value theorem to show that f of x has zeros between -1 and 0 and 1 and 2. So starting with -1, what you'll do is you'll take f of x and you'll plug in -1. I plugged that in everywhere that I saw x. So -1 cube it, then multiply it by 12. So it's -12, -1 square it, then multiply by -55. So that's going to be plus 55. I need to fix that. And then -1 times 18 is going to be -18, and then plus 40. And then when you combine all these together, you're going to get -45. So that answer came out negative. Now what we're going to do is we're looking between the interval of -1 and 0. So go ahead and find f of 0. So this will equal 12 times 0 cubed, which is 0, minus 55 times 0 squared, which is 0, plus 18 times 0, which is 0, plus 40, and that equals 40. And what you can note here is that we went from a negative to a positive, which means that yes, there has to be a 0 between -1 and 0. So because we have a sign change, yes, there's a 0. Now let's see if there's a 0 between 1 and 2. And you could always graph this on your calculator and look at the 0 between those two numbers. But this is how you would do it algebraically. So the first thing you would do is find f of 1, and then you would find f of 2, and then you're going to see if you get a sign change. So you can stop the video and try that. F of 1 is going to end up equaling 15. F of 2 is going to equal -48. And so you can see that I went from a positive to a negative. And so since there's a sign change, yes, there is a 0 that's going to occur between x is 1 and x is 2 because of the sign change. And that's what the intermediate value theorem is. So example 10 is going to get us ready for calculus as we begin to explore maximums and minimums. So let's look at this application problem. It says you cut equal squares from the corners of a 22 by 30 inch sheet. And so I really like to draw a sheet. So here is my sheet. And I'm going to take out the corners. And if you do this at home, it's really fun. You can cut out squares out of the corners, and then you can fold up these right here, end up being your flaps. And you can fold up your flaps, and you're going to make a box. And then we're going to try to write a formula for the volume of that box. So it says it's 22 by 30. So this would be 22, and that's the width. And then 30 is the length. And we don't know how much we're cutting out. So like we're going to cut out X and we're going to cut out X. And these little squares are X by X. Okay, so you can see we're cutting out these X's, which are squares, and X is the length of those. All right, it says we're going to make a cardboard box. So we'll fold up those flaps, make a box, and it says what size of squares would you need to cut, what size of squares would you need to cut from the corners in order for the volume to be exactly 300 cubic inches, so inches cubed. So let's talk about volume. We know volume is length times width times height, correct? So volume in terms of X, that's how much we're cutting out of the corners. If I look at the length, I have 30, but I'm cutting out an X and an X. So the length is 30 subtract 2X. The width, the entire width is 22, but I'm cutting out X, I'll highlight it. I'm cutting out X here and X here. And so this is X length and this is X length, which is 2X. So that's what I'm subtracting for the width. So I take the total width of 22 and I take out subtract 2X. Now when I fold this up, here's the flap that's going to fold up. and that's going to be x height, all right? So the height is going to be x. Now, when you multiply this all out, you're going to get a cubic equation. I like to just put it in the graphing calculator, just like this with the parentheses, all right? And then when we're looking for the volume to be 300 cubic inches, this V of X, we want it to equal 300. So this would be 300 times 30 minus 2x times 22 minus 2x times x. And so I'm going to grab my graphing calculator to finish up this problem. Okay, so we are going to go to y equals, and we're going to put in that equation. So use your parentheses. They are above the 8 and the 9. And again, you could multiply this all out, first, outer, inner, last, and then distribute the x. And you're going to get a cubic function. So we have 30 minus 2x times 22 minus 2x times x. And make sure you use the subtraction key, which is above the add symbol, and not the negative key down on the bottom. All right, now, if you were just to graph this in a regular standard window, you're not going to see much. So if I just did like a zoom 6, that doesn't really help me, does it? So we want to fit a window to our situation. So let's go to window, and the X is how much we're cutting out of the corners of the box. And since I can't cut negative corners out, I'm going to start my domain from 0. Now the width is 22. So if I cut in 11 and I cut in 11, then I don't have any more paper to cut because the total 11 plus 11 is 22. So the domain is going to be 11, not including, because you still have to have paper to cut. And then the volume, because I'm doing length times width times height, that volume, which is what Y stands for, is going to get really big. So we might just want to go like from 0 to 2,000 maybe, and count by hundreds so we don't get lots of little tick marks. And then if we hit trace, we get a very different graph, okay? So if I wanted to know what's the most I can fit in that box, like what's my maximum volume, then I could simply do second trace, which is calculate. I could trace the maximum, which is number 4. And then I would have to be to the left of the highest point, enter, to the right of the highest point, enter, and my maximum volume is 1,233.809 cubic units. And that's when I cut 4.182, does it say what we're in? Inches out of the corners. Okay, well, the question in our notes asks us for, it says, what size squares would we need to cut to get a volume of 300? So I'm going to go ahead and clear my history because it's getting kind of messy down there. And then I'm going to go back to y equals, and all I'm going to do is go to y2, and I'm going to put in 300. And I really like my window because I know it includes 300. That line might be kind of low, but I think that I'll still see it. So when I hit trace, you can see inside my domain, make sure you're in your domain. I'm going to hit 300 here, and I'm going to hit 300 here. So there's actually 2 answers. So you're going to do second trace, which is calculate. And then you go down to intercept, so number 5. And you can arrow down to number 5 and hit enter, or you can just type the number 5. And then let's left arrow all the way up and around, left arrow, and we're going to get close to this intersection. Hit enter for the blue curve, enter for the red curve, enter for your guess. And it says that I cut 0.492 out of the box in order to get a volume of 300. All right, so go ahead and write that number down in your notes, 0.492 inches. All right, and it gives me a cubic volume of 300 inches cubed. Okay, so we go again, second calculate, and we're going to go down to intersection. Now, we only are going to have two answers because otherwise we're out of our domain, which means there's no paper to cut. So the problem wouldn't make sense unless we're in our domain. So we come over to this one, we hit enter for the first curve, enter for the second curve, enter for your guess, and I'm going to cut 9.558 inches out of each corner of that sheet. And that's going to give me a volume of 300 again. So this is really awesome. Remember that we're rounding everything 3 places. So I'm going to stop this and write that into my notes. So you can see that I filled in my solution. I have 2 answers and my domain does not include 0 or 11. Otherwise, I can't make a box. Example 11 is showing us how we can write a polynomial function. So writing a polynomial function, I could say f of x is equal to, and then it's x subtract the 0. So x subtract negative a half, x subtract the 0. And I have 2 of those. So x subtract the 0. And so when we multiply this all together, I am going to have a polynomial function that has those 3 zeros. So if you recall, it's always x subtract for the factor and then the 0. Now, this part I could write as 2x plus 1. And then I have x subtract 3 times x subtract 3. Oops. X subtract 3. Now, something to note, the reason why there are many correct solutions is I could put any number here in the front for A. And if I change the vertical stretch or the vertical shrink of the graph, the zeros are still going to be the same. I'll still have zeros of negative a half, 3, and 3. Now that one, I'm getting a bounce because getting 3 twice is a multiplicity of 2, which means there's going to be a bounce in the graph. All right. So I will go ahead and just multiply this all out. I could do this part first. So I get x squared subtract 6x plus 9 and 2x plus 1. And hold on, my son's TV is really loud, so I'm going to go tell him to turn it down. All right, I am back. I'm super tired, only had 2 hours of sleep last night, so I hope you email me with some mistakes. I'm sure you'll find some. But I really like to multiply this using this box method. So I took x squared subtract 6x. I wrote it across the top, plus 9, and then multiplied by 2x plus 1. Creating boxes makes it really nice. It organizes my work. So I have 2x times x squared, and that gives me 2x cubed. It's like finding the area of a rectangle, length times width. So that's 2x cubed. 2x times negative 6x is negative 12x squared. 2x times 9 is 18x. Then we start again. The length of this is x squared, and this is 1. So 1 times x squared is x squared. 1 times negative 6x is negative 6x, and 1 times 9 is 9. And the reason I really like this method is now what I can do is I can simply add together things that have the same exponent, so like terms. So I can add the x squareds together, I can add the x's together, and I'm home free, ready to rock and roll. If I can get my pen to work. Come on, pen. And so here I go. I've got 2x cubed. So f of x is equal to 2x cubed. 1x squared minus 12x squared is subtract 11x squared. Negative 6x plus 18x is going to give me 12x. So plus 12x. And then I have plus 9. All right, and there is my final answer. This is a function, polynomial function, that has zeros of negative 1/2, 3, and 3. And if you're not sure, graph it and see if those are your zeros. All right, let's look at B. So B, 2 plus the square root of 11 has to have a conjugate, all right? And the conjugate that goes with it is to subtract the square root of 11. So it's A plus B, A minus B. So if they were only to give you the 2 zeros here, you would add the third 0 because those always come in conjugate pairs. So these complex zeros here always come in pairs. So if they don't give you the pair, you invent the pair. All right, because you know it's there. So let's go ahead and see what this looks like for us. So we have, if I want to use f of x again, so I have f of x is equal to, the first 0 is really easy. It's x subtract the 0. And that's what the 0 looks like in factored form. If you were to put that equal to 0, you would get 3, which is right here. Now I have x subtract, and then I'm just going to put this 0 in red. And make sure that you use parentheses because you're subtracting more than one thing. You're subtracting the entire thing, 2 plus the square root of 11. And then we have x subtract, and now again use parentheses, and I have 2 subtract the square root of 11. So there are my conjugate pairs. This is A plus B, and this is A minus B. Okay, so what we're going to do now is we're going to do some reorganizing. We're going to take the negative and distribute it through, and the negative and distribute it through. So when I distribute, I get x subtract 2 subtract the square root of 11, and x subtract 2, and a negative times a negative is plus the square root of 11. And what I want you to notice here is that we have a really cool pattern of conjugates. And so I can group x minus 2. Those are identical. So that would be your A. And then you have a subtract root 11, and you have a plus root 11. So that would be your B. So what's happening here is you have an A plus or an A minus B and an A plus B. So if you take x minus 2 times x minus 2, all right, that's first times first. And so x squared subtract 4x plus 4 is what you get when you do first times first. Now, the cool thing is because this is an A minus B and an A plus B, the outsides and the insides are going to cancel each other. So now all I have to do is last times last. And a negative times a positive is a negative. The square root of 11 times the square root of 11 is 11. And that is going to be multiplied by the x subtract 3. Okay, so now I'm ready to make my box again. My picture is kind of in the way, gosh darn it. But I have up top x squared subtract 4x, and then 4 subtract 11 is going to be negative 7. And then across the side is going to be x subtract 3. And notice that subtract 3, you always put the sign with the number behind. And so let's see if I can move me. Hi. I'm going to move me up here and let's see if that works. So now I'm going to draw my boxes, and you can see where the signs are is where you draw the lines. And again, the sign always goes with the number behind. So x times x squared is x cubed. X times negative 4x, negative 4x squared. And x times negative 7 is negative 7x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4 is 12x. And negative 3 times negative 7 is 21. All right, and then we're just going to add those together, and that's going to give me some, that's going to give me my final answer. I don't know if I can get this to scroll down a little bit. What do you guys think? Oh, ta-da! So I scroll just a little bit so I can fit my answer in. So I have x cubed. So f of x is equal to x cubed. And then the negative 3x squared and the negative 4x squared is negative 7x squared. And then 12x subtract 7x is 5x. And then I think that's a plus 21. And I'm going to highlight that. So there is a polynomial function, and it has these zeros. All right. So this is it for this section of notes. The you try is exactly that. You are supposed to try it. So with the you try, let me remind you how you sketch this without a calculator. First, you look, and I'll put them over here. First, you look for the degree and the leading coefficient so that you know which way your ends are going. Are they both up? Are they both down? Is one up and one's down? Second, you're going to find your zeros, and you're going to determine their multiplicity. Do they bounce or not? Next, I'm moving me down here. Okay, next, you are going to find the y-intercept. So that means you plug in 0 for x and you find y. After you do those three things, then you're going to do roller coaster curves, nice, smooth, round turns, curves, because these are polynomial functions. Good luck. Try the you try.